If you haven't solved this problem in big of one memory, stick to this video. Let's gonna talk how we can solve this in big of one memory. So let us start by reading the question and then the brute force and then the optimized solution which we can solve in place. That means without using any extra space, right? So we are given with a zero indexed, zero based permutation like nums is an array which is zero indexed. Build an array answer of the same length where answer of I is equal to nums of I. For each 0 is less than nums dot length or 0 is less than or equal to I less than nums dot length and return it. A zero based permutation nums is an array of distinct integers from 0 to nums dot length minus 1 inclusive. So let us start by just taking the first example, and but before that let us consider the constraints which are 1 lesser than or equal to nums dot length less than or equal to 1000. That means we have only value still 1000 and nums of I will be less than nums dot length. So if there is an array of length 5, then the maximum value that we can get is 4. So we can get 0, 1, 2, 3, 4. That's it. The elements in nums are distinct. That means we will get every number from 0 to n minus 1. Now I have 0. As they said, answer of I is equal to nums of I. Nums of I. Let us see what they mean. Answer of I. That means here if I take an array answer and I'll store the result what I get. Nums of, write it again. Nums of, what is nums of I? Nums of I. Nums of I is 0. We are still at index 0. Nums of I is 0. Nums of 0. What is the value? Nums of 0 is 0. Okay. Till now, I think it's understood and clear for you. Now, use the same thing again. Nums of 0, let me remove it from here. Now, I am at index 1. I is equal to 1. Okay. Nums of I. Nums of 1. Okay. Nums of 1 is 2. Nums of 1 is 2. Now, what is nums of 2? Nums of 2 is here 1. Let me write it. Nums of 2 is 1. So, I'll place answer of I is equal to nums of I, which is nums of 2 is 1. Now, let me take this 1 right here. Next index is 2. I is equal to 2. Now, I is equal to 2 and nums of I. Wait a second. Nums of I. Nums of 2. I is equal to 2. Nums of 2 is 1. Nums of 2 is 1. Now, what is nums of I? Nums of 1. What is nums of 1? So, if we haven't stored this nums, if we change this nums into 1 here itself, then we would get a wrong answer. So, I'll tell you how you will store in the nums and how do you get it, but wait a second. Nums of 1 is 2. So let me write it over here 2 and I have a 3 here. Nums of I is equal to 3. Now nums of 3 is nums of 3, let me write it. Nums of 3 is 5. Nums of 3 is 5 and I have nums of 3. Nums of 5 is 0, 1, 2, 3, 4, 5. Here I'll write 4. Okay. Now I am going to the next index. I'm going to the next index 4. I have 4. Now I have nums of I is 4. Nums of I is 4. Nums of I is 0, 1, 2, 3, 4. Nums of 4 is 3. Now nums of I is 3. Nums of 3, 0, 1, 2, 3. Nums of 3 is 5. Let me write it over here. Then let me remove it from here, and I have the next index as 5. So I have 5 as I. Nums of I, if I write nums of 5, 0, 1, 2, 3, 4, 5. Nums of 5 is 4. Okay. Now I have nums of 4 to be placed in answer of I. Nums of 4, 0, 1, 2, 3, 4 is 3. I think this is clear for you. I simply take answer for this. I'll take an algorithm. The intuition is nothing but to create an array of size n. Many people have forgot to initialize the size. That's why they get a runtime error. Remember, you cannot assign values you cannot assign values to the array which is empty, right? You cannot initialize array or a list in Python which is empty, and you cannot even access array of 0, array of 1 like this. So initialize array size to be n. Okay. To create array of size n. Now after that, iterate from I is equal to 0 till n minus 1 inclusively. I think you know what inclusively mean. So at this point of time, answer of I is equal to nums of I, and at the last return answer. But it's not over for now. So this is the answer, the code. You can get the description link in the description, but it's not over. How can we solve this in big O of one memory? That means we are not using any extra space, right? Without extra space, let me write it over here, right? Without extra space. Now I know that I have this nums of I is equal to 0, 2, 1, 5, 3, 4. Now what is the old value? I also take this answer array. Now what are the old values? What are the new values? So here the old value, I'll write it. I'll write with a another color, right? Old value and new value. Old value is 0. New value is also 0. This doesn't make a difference. But let me take for this. Old value is 2 and the new value is 1. So at this moment or at this place, I will store 2 plus 1. 2 plus 1. But wait a second. If I store 2 plus 1, then I will get 3. How do I get the old value and new value? New value is 1. So I multiply 1 into some number x, right? Okay. Okay. Now you can ask me how this will help you. 1 into x, you will be doing 1 into x, you will be doing one new value into x, new value into x, then adding old value, new value into x, adding old value. Now I will do that. I'll do that. First thing, let me take x as 6, right? Just a random number. I am not telling any intuition, but just a random number of 6. 1 into 6, I got 6 plus 2, I got 8. So here I will place 8. Okay, I am placing 8. Now my intuition is to get all these old values and new values. Let me name this as code, right? Something like code. Now we need to encode this. Now we need to decode this. Now I have 1 into 6 plus 2, right? This is new value and this is old value, right? Remember, remember, old value will be lesser than n, right? I think it's clear. Old value is lesser than n. Now to get a new value, I have given like 2 into 6 plus something like 5. Then the value will become 2 into 6 is 12 plus 5, 17. Now if I divide with 6, I have multiplied with 2. That means the new value. I have multiplied with the new value. So if I divide with 6, the value which so here I have multiplied with 6. So if I divide it, the total number, if I divide it with 6, the one which I multiplied, then what will I get? 6 into 2 is 12. 6 into 3 is 18. But 2, right? I'll get 2. Now, you might be thinking, bro, how you get the old value? Here the old value is 5. How do you get it? It's simple, right? 17 percentile 6 will give you the old value, which is 5. So for new value, you need to do this. For the old value, you need to do this operation. I think for now, it's clear for you. Now, let us take this again and approach or change this nums of I every time. There will be something like an edge case. I'll tell you what it is. Now I have old value, I have new value, I am multiplying 8. Why 6? Why 6? Why not 8? Why not 10? Why not 12? Because the size of array is just 6. Now if I took something like 8, just imagine I have took something like 8. For this answer, definitely I would get a wrong answer, right? If I took something like 5 plus 2 into 8, 2 into 8, 8 is a 16 plus 5. But every time I will I do the percentile operation for this, then I would get a wrong answer, right? I would get a wrong answer. So that's why to get an old value, that would might get a conflict, and you'll be using a modular operation with the n. So that's why I'm not using another number rather than n. Old value, new value into n. So old plus new into n. Old value is 0. So it's the something like nums of I. Here it is. Nums of I. Here it is. Right? New value is 1. 1 into 6. 1 into 6. Okay. 1 into 6 is 6 plus 0 is 6. Now I have the old value as 2 and the new value, sorry, it is 0. That's confusion. New value is also 0. 6 into 0 is 6. Sorry, 6 into 0 is 0 plus 0 is 0. What is the new value? New value is nums of I. Nums of I is 1. Nums of 1 is nums of 2 here. Nums of 2 is 1. So the new value is 1, right? Into 6. 6 into 1 is 6 plus 2 is 8. So here I am storing 8. I think it's clear for you. Here I have stored 8. Now I go to the next index. Wait a second. I remove this. I is equal to 2. Okay. I is equal to 2. Now the old value is 1. Now what is the new value? Old value is 1. What is the new value? Nums of I. Nums of 2. What is nums of 2? It is 1. Nums of 1. At nums of 1, I got 8. But actually, it is 2. I got 8. But actually, it is 2. Percentile 6. So, just imagine if you have used 8 instead of 6. I think the doubt is clear for you. If you have used 8 instead of 6 and did this operation 8 percentile 8, you would get 0, right? So that's why use the size of n. I think for now it's clear. Yet percentile 6 is 2 into 6. 6 to the 12 plus 1 is 13. Okay. Now at this I am storing 13. Right. Okay. Now the I value is 2. I value is I value is 3. And what is nums of 3? Nums of 3 is 5. Nums of 3 is 5. Okay. Nums of I, right? Nums of 3 is 5. Nums of 5 is 4. Okay. So the new value is 4, but every time, no matter if it is greater or less, I will do mod operation. Plus the old value is 5. So 4 mod 6 is 4. 4 into 6 is 24 plus 5 is 29. Okay. Here I am storing 29. 29. Now let us see what happens here. Now I have 3, right? So I is equal to 4. I is equal to 4. Nums of 4. Nums of 4, I got 3. So at this point, I got 3. Nums of 3 is 29. Nums of 3 is 29. So the new value will be nums of I 29 percentile mod 6 6 4 6 fours are 24, but remainder is 5. So 5 into 6, and what's the number at I is equal to 4? Number is 3. So plus 3. 5 6 are 30 plus 3 is 33, right? Okay, it's okay. Now I got here 33. Now I have I is equal to 5. Okay, I is equal to 5. Nums of 5. What is nums of 5? Nums of 5 is 4. What is nums of I? Nums of I is 4. Nums of 4 is 33, right? Nums of 4 is 33. Now, old value 33, percentile 6, mod 6 is 3 into 6 plus what is the value at the old value 4. Old value is 4. This is the new value, which is 33, but I am doing a mod operation. Then 6 threes are 18 plus 4 is 22. Now what I'll do is just take this. Wait a second. Just take this and let us compare. Do you get the same answer or not? The same answer or not? By nums of I by 6 is 0. Now nums of 0 by 6 is 6 ones are 6, so it's what I am doing division operation, not modular operation. 6 ones are 6 and the remaining will be 2, which is the old value. No need. Now 13 by 6, 6 6 twos are 12. 6 twos are 12. So 2 here. 29. 6 fours are 24. Okay. 6 fours are 24. 6 fives are 30. Right? 6 fives are 30. 6 6 threes are 18. So 6 threes are 18. I think clear. So this is how you solve this problem. I simply write the algorithm here. So first thing is for int I is equal to 0 and going till n minus 1 inclusively. Okay, going till n minus 1 inclusively. Okay, now nums of I is equal to nums of I, which is the old value. Okay, nums of I plus the new value is nums of I mod what I am taking n into n. Okay, now to change the answer. For do the same thing. Int I is equal to 0 inclusively n minus 1, nums of I is equal to nums of I by n. Okay, at the last return, sorry, nums, let me take a semicolon everywhere. Okay, then here, then here, and int I is equal to, I am changing it to the code, that's it. So I is less than n, then I plus plus. Okay, I is less than n, I plus plus. I is less than n, then I plus plus. Right? So this is the code, and int n is equal to nums dot size. Okay, I forgot the semicolon. Right? So till now I think it's clear. I'll just paste this code here, then you'll get, let me check I am getting the correct answer or not. Yes, it's okay. So this is how you solve this problem. I think it's clear for you, and if you have even any doubts or something like how one-on-one mentorship, so one-to-one mentorship, sorry, one-to-one mentorship, you can just reach me out in TopMate or in LinkedIn. Thank you.